Okay, so we're gonna be doing acid catalyzed transesterification. It really is the same thing as um, acid catalyzed hydration, but literally, whatever your solvent is, just replace that right here. So whatever how many carbons that is, just count it. You'll be alright. Okay, so we have pH, whatever. Just draw it, whatever. Okay, so since we have an excess of our solvent and we have H2SO4, we're gonna protonate it, and so we're in acidic conditions. So just make sure you can't form a negative charge. Okay, so yeah, just put like a little H there, and he has an H, so he's he's positive, right? So our he's gonna take an H, and so we can't do nucleophilic addition because that would form a negative charge. Okay, so good right here, and we have this H now. There's a positive. We are activating the carbonyl, so just draw some resonance structures, push the electrons toward the positive charge. So he should be good. And now we have a plus thing right here. If you draw one more, if you were to move the lone pairs of this onto here, onto that, we would have a positive charge here. Just pick the second best resonance structure, and then you should be alright. Okay, so we're picking the second best, which is basically the carbon that we're basically picking the thing that doesn't have an octet. And so, let me get the light on. I think it's a little dark. Alright, we good now. Wait. Yeah, we good. Yeah, so we're gonna pick the one. Yeah, yeah, so what's gonna attack it, right? We have an excess of what? We have an excess of the oxonium. Honestly, I don't even know what it's called. The excess of an alcohol. To be honest, I think it's an alcohol. So we have this alcohol right here, and he's gonna attack it. One, two, three. Okay, good. He's gonna attack right here, and so if it attacks there, it's gonna deprotonate. Okay, I'm not gonna be lazy. I'm gonna draw all the steps. Yeah, we're gonna form a oxonium ion, or honestly, I don't even know. It's just whenever oxygen has a positive charge. Is that one, two, three, four? Okay, good. And so now, since we have an excess of the alcohol is gonna. Is it alcohol? I don't even know. We have an excess of it. It's gonna deprotonate it, right? This is the thing that's gonna take away that thing and make it normal. Okay, good. So so now we have our thing, and we have a neutral tetrahedral intermediate. Okay, one, two, three, four. Is that good? That should be good. So this is neutral, right? And so we want to make another ester. So which one are we gonna kick out? We're gonna kick out the former ester. But if we were to kick it out like this, right, or something like that, if we were to kick it out like that, we would form a negative charge. And since we're in acidic conditions, we cannot form a negative charge. So we're gonna have to protonate this first. And so what do we have in excess of? Or not even, we can answer that question, or you could just look at this, right? What are we forming right here? We're forming this plus charge right here. So honestly, I think a good habit is whenever you form something, just draw it, because you might end up using it later on. I don't know. Okay. So he has a plus charge, so this oxygen is gonna now take this H, and he's gonna push it onto here. So now we're adding an excess, like according to the Chatelier's principle. If we add an excess, adding an excess of the reagent, the system is gonna respond by consuming it, and so it's gonna consume it. Honestly, I don't even know where the consuming part happens. I'm just, but that's what happens somewhere in this mechanism. I just don't know where. Yeah, so this is plus charge. Um, yeah, so he's gonna leave, and so now we have this. Um, we're almost done, and so now we just need a. Now we form a carbocation right here, and so now we're almost done. We just need to like we gotta draw some resonance structures, so we could draw it into the form where like we're making a resonance structure. And we're gonna pick the resonance structure that's gonna look the most like our product, which is this. So if we were to push electrons right here, now this that looks a lot like our product, right? Which do we want? And if you draw one more, um, so yeah, so right here, it should be an H right here. I'm sorry. There should be an H right here. Yeah, there should be an H right there. There should be an H right here. There should be an H right here. And there should be an H right here. And there should be an H right here. Okay. Whoa, 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 whoa. Yeah, I'm right, I'm right. I'm bugging. I'm bugging. Okay. So, which one looks the most like our product, right? This is the one. Even though this is the minor, this looks. Even though this is the minor, we're gonna wanna get this one because okay. So what do we have in excess of? We have an excess of, um, we have an excess of the alcohol. So the alcohol is the one that's gonna deprotonate it. So, right here, and then and I think I'm doing something wrong. Let me just recheck my work. So right here, um, that leaves, and so if we were to push electrons right here, um, yeah, this I'm right. Okay, yeah. So you push electrons on here, and this goes on to the oxygen, and so now, oh sh, oh I'm sorry. This final resonance structure is right here. I should have paid more attention. Yeah, it's right here, and that's the final resonance structure. It doesn't really matter, but you just have to draw it. My teacher probably wants it. So yeah, this is the final answer. Once we deprotonated that, I highly doubt I'll even get this type of question and mechanism, but just form another ester and damn not fun. We're gonna want to regenerate the the acid catalyst. And then also, I mean, since we formed this, right, we're gonna form right here. That's really it. So this is basically the exact same thing. This is basically the exact same thing as acid catalyzed hydration, but this is called acid catalyzed transesterification. Instead, we're just honestly, I don't know the difference. Honestly, I don't even know what hydration means. I mean, I have an idea, but I don't really know exactly what it means. But transesterification, I know that if you have transesterification, you have an ester, and we're gonna make it into another ester. And it's probably the easiest question because you just have to look at the solvent, and the solvent itself will just tell you what the product will look like.